First of all, I wish to thank the management of PSN College, HOD of Electrical and Electronics Engineering Department. Thank you for giving me this opportunity. In this session, we are going to see basics of electric vehicles, types of electric vehicle, and also we are going to see basics of batteries. In simulation also, we are going to do some analysis about charging of batteries. This is the outline of my presentation. Before getting into electric vehicle, I wish to tell a few history. We thought that most of us, we thought that electric vehicles came into picture within 10 to 20 years only. It's not so. Since 1896, 1890s, even 1890s, electric vehicles are there. So in the picture, you can see the paper news. Electric car wins first American auto race. This was printed on 9/7/1896. So,
excuse me, Prince sir. Please put the record button, sir.
ma'am, it's already in record, I think.
Okay, okay, sir.
Kindly ensure that, ma'am.
Okay.
It shows me button pause, so I think it's already in record.
Okay, okay, sir.
Okay. So, due to the evaluation of refining industries, that is crude oil refining industries, the IC engine based vehicles coming larger quantity, and also a few negative points in electric vehicles also there. That's why in that days electric vehicles not booming that much. Nowadays we are focusing on electric vehicles because of I think participants, kindly mute your mic. Nowadays we are focusing on electric vehicle because of environmental pollution as well as reducing the fossil fuel consumption. So these are the two reasons which we are moving to electric vehicles. This is the picture which shows the IC engines. We already know we are using petrol, diesel for the fuel of vehicles. Nearly 98 to 99% of our today's vehicles are this IC engine based vehicles only. The main disadvantage is we are consuming more fossil fuels and the pollution is more in IC engine based vehicles. That's why we are moving to electric vehicle. These are the different types of electric vehicles. Achieving hybrid electric vehicle, plug-in hybrid electric vehicle, battery electric vehicle. From this picture, you can clearly know the what are the main components, what are the advantages and disadvantages of each vehicles. First, we can see hybrid electric vehicle. You see this vehicle. This has IC engine, and also for regenerative braking, they are using electric motors for storing that energy and assisting the vehicle using the motor. We are having batteries there. You can clearly see here IC engines, and for regenerative braking purpose, electric motor and batteries is there. For IC engines, we are giving petrol or diesel or even gas. So this is in hybrid electric vehicle. In plug-in hybrid electric vehicle, you can see the batteries. The additional thing compared to hybrid electric vehicle is plug-in. So what is that plug-in? That plug provides charging facility for the batteries. Here the charge only from generators as well as from the regenerative braking as well as some generators placed at the wheels. We can charge the batteries. No external charging is there. So we couldn't store larger energy. That purely depends on movement of electric vehicle, as well as the brake, how much amount of energy we are receiving. So we can't charge the battery externally. But in a plug-in hybrid electric vehicle, we can charge that battery with the help of external charger. That is the additional advantage. So we can have bigger size batteries. That is larger amount of storage capacity batteries can be used in plug-in hybrid electric vehicle. So if you want to operate the vehicle with the help of batteries, means you can operate here. That is not possible in hybrid electric vehicle. You can store energy during the braking also. Normally, we studied about three type of brakings in our machines. One is dynamic braking, that we called as rheostatic braking, and plugging, as well as regenerative braking. Mechanical braking is also there. In most of the vehicles nowadays, we are using mechanical braking. The kinetic energy stored is nullified with the help of brakes, mechanical brakes we are applying. So due to that, huge energy is wasted. With the help of regenerative braking, we can store that kinetic energy in the battery. That is the advantage. If you are using electric vehicle inside city, means we have to apply brake more times. That time, huge power, huge energy can be saved in electric vehicle. So ultimately, the efficiency of vehicle will get increased. So here the possibility is we can charge the battery externally. If gasoline and diesel is not there, means you can operate that vehicle for fewer distance with the help of this battery, because you are having the motor. That motor will drive the vehicle. Here it is not possible because the battery capacity is very less compared to this plug-in hybrid electric vehicle. So another thing is what we focusing is battery electric vehicle, battery operated electric vehicle. If you see, the battery size is huge. Here there is no gasoline or diesel, petrol tanks here. No IC engine is there. Here we can able to generate power during the braking also. We can continuously run the vehicle with electric motor. So this vehicle is alone, the pollution is very less. For other two, the pollution will be there, depends on how much fossil, that is diesel or petrol we are using. In order to fossil fuel consumption, in order to avoid definitely we all should use battery electric vehicles. So these are the comparison between three types of electric vehicles: hybrid, plug-in, and battery electric vehicles. You can see the difference. Battery is very less capacity here. Here capacity is somewhat moderate. Here huge capacity. That depends on mileage coverage. Here also we can charge the battery with the help of external charger. So this is also another one picture which shows you clearly about the comparison of all the four. The previous picture we didn't see the petrol operated vehicle. Here in petrol, we have to operate only the IC engines alone. Then we need a petrol or a diesel. Here, plug-in electric vehicle already we saw in the previous slide. Battery electric vehicle. Range extended means we have to additionally use that petrol for charging the battery also with the help of chargers. We can see in later slides. These are the main. I request the participants to mute your mic. Okay, these are the main things inside the electric vehicles. You can see transmission, medium and motor generator. This we can operate in both modes as well as motor or generator, and polytronic converters will be there, and then energy storage. It may be battery, ultra or super capacitor, fuel cell are used to store the energy, and a controller to control the things inside the electrical vehicle. So this is the picture which shows you clearly what are the main equipments inside the hybrid electric vehicle or electric vehicle. This is a combination of both IC engine as well as electric vehicle. If it is electric vehicle alone, that is battery electric vehicle alone, means no IC engines will be there. So that is the difference. Other components remain same. Only the controller things will be gets changed. That's the difference. So another type in HEV, that is hybrid electric vehicles, again classified into series, parallel, and series parallel. This is the picture which shows you clearly about the comparison. You see what a series means. Hybrid means that vehicle have both IC engine as well as electric motor. So if you see the picture, this series engine means all are connected in series: battery, inverter, and motor. Here also, from that IC engine, one generator is coupled, and from that generator, power is generated. That is given to the inverter, and it is used to drive the motor. So this type is called series type. Okay, no interconnection between that is IC engine to the transmission medium, that which we control the wheels. So there is no direct control of wheels using IC engines in series type. Whereas in parallel type, we can combine both. There is a transmission medium. Here, that vehicle, that is a parallel hybrid electric vehicle, can operate with the help of battery as well as IC engines directly. So power from IC engine directly drive the wheel, and power from battery can directly drive the wheel. Here it is not so in series. Inverter only. So that is the difference. Series and parallel is combination of both the things. It may be any, like series as well as parallel. So from this picture, I think you all understood about hybrid electric vehicle types: series, parallel, and series parallel. Lot of advantages and disadvantages are there. I think you can get directly from the picture. Depends on application, depends on the manufacturer. These kinds of vehicles are produced. We can see electric motors. Normally, two motors are used in electric vehicle. So here I have projected brush type, permanent magnet, and inductive. If you see in industries, two motors are widely used. One is brushless DC motor, and another one is induction motor. You see brushless DC motor, you know the circuit complexity, on a lot of disadvantages are there. If you see an induction motor, wide advantage, the control is very easy. But for electric vehicle, we need to have a better VFD controller. I think most of you know about Tesla, biggest electric vehicle manufacturer. They have achieved a lot of big things in electric vehicles. They have induction motor for their electric vehicle. But if you see Tata and Mahindra here, they are all mostly using brushless DC motor for driving their electric vehicle. So these are the comparisons. Main thing is torque weight ratio. If you see for induction motor, it will be lesser. So the weight will be lesser for the same capacity. So that's why most of us using induction motor for many industrial applications. In future, due to the emerging VFD technologies, all the vehicles, I hope they will use induction motors. Next, we can see basics of lithium ion batteries or batteries, even batteries we can say. Lithium ion batteries, I think you all know the energy density and power density both are good for this lithium ion batteries. And size, if you compare it with lead acid battery, which we are using in our home for our UPS. In our UPS, we are using, most of us, we are using lead acid batteries for the same capacity. For example, if you are using 100 Ah battery, 12 volt 100 Ah means the lead acid battery size will be very large compared to lithium ion. And also the energy density and power density both will be higher in this lithium ion batteries. That's why we are using these batteries for electric vehicles. We need to reduce the space and also we need to extract more energy. That's why we are using lithium there. Nowadays, due to explosive nature of lithium ion batteries, most of them they are focusing on other technologies. One is lithium ferrophosphate. A lot of material works research are going there. Another emerging is lithium ferrophosphate. In most of the cases, they are also preferring lithium ferrophosphate. The main parameters in batteries are C rate, watt hour, ampere hour, and voltage. So C rate, that is charging rate, that we in lead acid batteries also, in quality battery they will mention. If you are asking for a battery in any shop, surely they will ask about voltage, ampere hour. Most of the shops they didn't ask C rate. Now in most of application we have to focus on C rate also. So lead acid in our home, we have 0.1 CR, 0.2 C, that is C1 or C2 type. So this C rate is also very important. I will explain about what is C rate in later slides, and also we are going to see some simulation analysis for these parameters also about watt hour, ampere hour, and C rate. So later on we can see in detail. This is the picture shows regenerative braking. So we all know about kinetic energy. The equations also we know. Amount of energy depends on mass and velocity. About your vehicle weight and vehicle velocity. That amount of energy is stored as kinetic energy in the vehicles. If we are going to apply a brake, we are using a mechanical brake, means that energy gets nullified, because in order to stop the vehicle we have to provide the same amount of energy to nullify this kinetic energy. Then only the vehicle will stop. So instead of wasting that energy, with the help of generator, we can able to extract the kinetic energy stored in the vehicles. So that is the ultimate aim. So during running condition, the power, that is this motor generator set will operate as motor and drive the vehicle. Whereas in regenerative braking, this motor is operated as a generator to extract the power stored in the electric vehicle, and it stores that energy in the lithium ion battery or any batteries available in the motor. So why we need a lithium ion battery means a huge amount of power we have to extract within a short time. So at that time, even lithium ion battery cannot store that much power. Okay, that's why in most of the vehicles they are using ultra capacitor or super capacitor in order to store that huge power. So this is about regenerative braking. Here this picture will show both the things, battery as well as super capacitors. Supercapacitors will assist during starting of the motors and also during the storage of power during the regenerative braking. Why we need supercapacitors for starting? We all know, I think the next picture also, this is the picture. It shows you the starting current comparison of motor. It's also for a particular case. In many motors, it will be more than that. See the percentage full load current. It's around 550. It will be even 8 to 9 times also. So full load rated current is 100 ampere means that starting current will be 5 times more than that. Okay, so that is why supercapacitors are needed to supply that much huge power. That is mainly the huge current during the starting. Otherwise, lithium ion also can't provide that much power during the starting, and also during regenerative braking also we have to extract more power. That's why we are using a super capacitor or ultra capacitor in energy management system in battery electric vehicles as well as all the types of electric vehicles. Another storage technology is fuel cell. This is going to the actually Reliance. I think you all know how they are entered into communication market. They totally make all the communication company like PSNL, Aircel, and most of the companies they closed because of their entry. You all know how much they have analyzed the market. Now they closed all their most of the oil-based plants. Their main business is crude oil refining. So they have larger plants to store crude oils and processed petrol and diesel. Now they are converting that storage tanks into hydrogen storage tanks. They are going to invest nearly 5 lakh crore rupees in green energy. So they are going to make a lot of plans for hydrogen generation. See how they are wisely transferring their business to hydrogen. For sure, in next 5 to 6 years, batteries will be replaced by this technology, fuel cell technology. Even in our home itself, instead of battery, we may have a hydrogen storage tank, and from that hydrogen, we can convert that energy into electricity with the help of fuel cell. Fuel cell is nothing but chemical energy based energy conversion device. It converts hydrogen into electricity simply. The process is opposite to electrolysis. In electrolysis, we are converting electrical energy into hydrogen and oxygen. That process will separate water into hydrogen and oxygen. With the reverse process, we could able to generate electricity. I hope most of you know about fuel cells operation also. This is going to be the future in all the electric vehicles. Surely we will have a fuel tank, that is a gas tank, that we will store hydrogen. Then fuel cell will convert that hydrogen into electricity. Again, the same procedure. Instead of batteries in electric vehicle nowadays, surely in future we will have hydrogen also. In most of the research-based electric vehicle companies, they have even a bus, train, all they are operating with the help of hydrogen. So, due to the explosive nature and some issues in the storage, it is not commercialized full-fledged. We can expect within 5 to 6 years. That's why even battery manufacturers like Amaran and Excite, they didn't open big plants for lithium ion or lithium ferrophosphate. They are manufacturing in a very low quantity only. Okay, so our prediction in 5 to 6 years, this is going to rule the world. This technology, fuel cell. If you see, you can search in internet also. You can search like Bloom Box. One American manufacturing company, they are providing a supply for many corporates with the help of fuel cells. Our Indian government also tie up with that company. I think you know about GAIL. That is the central government undertaking company. They have a tie up with that company for manufacturing fuel cells. Okay, even NTPC, most of the companies they are working for this technology. We can expect a bigger change in near future. This is another one comparison, which again shows you clearly the comparison between all the vehicles, conventional, hybrid, plug-in, and all electric. You can see the source. Conventional only depends on fossil fuel, that is petrol or petrol, gas or diesel. Consumption will be very high. Emission also will be very high. In hybrid, the consumption of fossil fuel will be very less, not very less, less compared to conventional. But we are using batteries also in very minimal quantity, that is capacity. The emission is somewhat reduced compared to conventional. In plug-in hybrid, due to the availability of external energy storage, here battery capacity is extended. Due to that, fossil fuel consumption gets reduced, and the emission is reduced compared to hybrid also. Whereas in all electric, we only depend on electric energy. We didn't use any petrol, diesel, or gas. So no emission on the road. But during the manufacturing of batteries and the electric vehicle, that company surely emit CO2. But on road, if you see, no emission is there in all electric. Again, if all the generating stations should convert into renewable energy, then only we have to say the total emission is reduced. Or else, instead of CO2 emission on the road, the bigger power plants which generate electric power get more emission, because you have to store electric energy. For that, we have to generate electricity somewhere else. Okay, nowadays renewable energy are blooming up. Hope in future we will generate more power through renewable. Then only we can say all electric will have no emission. Until we can say in road, this will not emit CO2. Road air pollution can be reduced. Okay. The another comparison between electric and gasoline. You see the mileage coverage. You can see the disadvantages. If you see in electric vehicle, the mileage coverage 100 plus nowadays, it's greatly increased. I show you. Here, once you fill your tank, you can go up to 300 plus kilometers normally in all the vehicles. Hours to recharge the battery is the biggest issue in electric vehicle. So we can see some charging analysis also. For refueling the petrol or fossil fuel based sources, within a minute we can refuel it. The cost is also greatly reduced in electric vehicle, 2 cents per mile. Here it will be very high. So these are the comparison between electric and gasoline. Another one biggest advantage in going for electric vehicle is B2G and G2V concept. That is vehicle to grid and grid to vehicle. This is also a blooming area where we can make the power system to operate in a smarter way to have a better reliability and stability. So in a charging station, you can your electric vehicle can be operated in both the modes. You can charge or it can discharge. Why it need to discharge means to support the power system, to match the load demand, to provide a better reliability. So both the things will happen. So this will make a power system to operate with good reliability and stability in near future. So vehicle to grid means from vehicle power is fed to grid. That is why it is mentioned as V2G. That is battery, from battery power is fed to grid through powertronic converters and through various equipments between vehicle to grid. Then Z2V means grid to vehicle. So from grid power is given to the vehicle, electric vehicle to charge the batteries. This is G2V concept. So this also in smart grid it is possible. Companies are working there. Now Tata Power they have installed many charging stations in India. Even in Madurai itself we can see a lot of charging stations. Let's see some cars, electric cars available in market. This is the 2021 scenario. Hyundai Kona that will cover 452 kilometers for charge. If you charge a battery, you can go up to 452 kilometers. So this is the biggest achievement. For all the motors nowadays, the coverage is very high. Mercedes-Benz, they have EQC, MZ, ZSEV, Tata Nexon EV, it's around 312 kilometers. And Tata Tigger EV, this is 213. It's the old model. The upcoming models are having reduced charging time and high mileage, high kilometer coverage. And Mahindra E-Vertigo, this is also old model, both 2E2O plus 140 kilometer and 181 kilometers. So this is a 2021 scenario. If you see a 2022, more changes may happen. Let's see international cars. This all in Indian market. You see US Tesla. I hope all of you know about Elon Musk and their lot of innovations. Starlink and spaceship they are manufacturing. The Tesla they have achieved a big thing in electric vehicles. They are claiming that their batteries, they are also manufacturing batteries. Their batteries they can charge within 3 to 4 minutes. So 20C they are claiming. After the serious discussion, I will tell you what about what is the meaning of 20C. Now you can see the parameters from 0 to 60 miles per hour. You can reach within 1.9 seconds. So we have to provide a huge power. That much amount of huge power has to be given from your batteries. That is the biggest challenge in the electric vehicles. They are achieving that. Also, miles per top speed at 261 and 250. Mileage coverage for fully charged, you can go up to 620 miles. If you convert it to kilometers, it will be more than 750. So they are going to rule the electric vehicle markets. And the capacity, seating capacity, the price will be very high. In storage models also that you search in internet, you can find. These Tesla company, they are using most of their vehicles, they are using induction motors. That is their uniqueness. We already see about the starting current issues in electric vehicles. Now we can see the basics of batteries. So capacity normally indicated in ampere hour or watt hour. Voltage rating we all know in volts. In C rating, they have mentioned C1, C2 or C5, or else 1C, 2C and 5C. Like that, they will mention the C rates, that is charging rate. What does 1C means? 1C means, for example, if you are charging a battery of 10 Ah, if a battery rated 10 Ah means, if the C rating is 1C means you have to charge, you can charge the battery at a rate of rated specification that is mentioned in the battery, that is 10 ampere. So that is the meaning. 1C means 10 ampere, the rate of 10 ampere you can charge the batteries. Whereas in 2C, if that battery is mentioned as 2C means you can charge a battery with the double the times of its rated capacity. Then it is 20 ampere. So 10 Ah 2C battery means you can charge that battery at 20 ampere rate. Whereas in 5C means you can charge that battery at a 50 ampere rate. That is the meaning. If it is indicated previous to C. If that is after C means 0.1. So point at the rate of 0.1 C. So 10 ampere hour battery C1 rated means you can charge at the rate of 0.1 rated capacity. 0.1 means 0.1 into 10 ampere. That will come around 1 ampere. So 10 ampere hour C1 battery can be charged at a rate of 1 ampere. C2 means 2 ampere for the same capacity. C5 means 5 ampere. That is the meaning. So this C rate normally denotes the charging current rate of the battery. This will decide the charging time of the battery. For example, you are having a 100 ampere hour 12 volt battery means you are charging at the rate of 1C 100 ampere means at 1 hour the battery completely gets charged. If it is at 0 SOC, state of charge is 0. Assume that you are having a battery with a state of charge 0%. The battery rating is 12 volt 100 ampere hour. If you charge that battery at 1C rate, that is 100 ampere hour rate means at 1 hour your battery gets completely charged. For the same case, if your C rate is 2C means you can charge that battery with 200 ampere. So you can completely charge the battery within at 30 minutes, not within at 30 minutes. That is the meaning. So like that, if your C rates of the battery gets increased means the charging time of the battery gets reduced. Only thing we have to provide that capacity converter, all those things. That is possible. Even in we are using power converters for transmission line. In megawatt scale, we are producing. So for charging the battery, the issue is not the capacity of the converter. Issue with the materials of the battery, how it is behaving, how it is accepting the charging characteristics. All those things plays the matter. Most of our students, project students, they are focusing on batteries to reduce the charging time. They are focusing on the converters only. It's not so. The battery is ready to take that charge means we can able to deliver huge power. That is not the issue. Here, the issue is with the battery materials. So Tesla claiming that they have battery with 20C rating. Then you put the calculation. So their battery is fully charged within 3 minutes. This statement they have told during 2090s. So now they may have more than that also, but I didn't get that detail these days. In 2019 itself, they told that they are having batteries with 20C rate. Within at 3 minutes, you can able to charge the battery. Only thing is we have to focus on lifetime and health of the batteries. For that, they are reducing the charging time to the optimal level. But that is the biggest achievement. So these are the basic thing. You all know what is if you see compare a capacitor and a battery. Capacitors, they can discharge huge power with short duration, whereas batteries, they can discharge less power for longer duration. So that is the difference. So in order to store and during the starting of vehicle, in order to assist the motor, supercapacitors are used. There the power density will be higher, energy density will be lower, whereas in lithium ion both will be higher in the range. But by comparing supercapacitor and lithium ion battery, in the case of power density, supercapacitor will be more. That's why we are using along with lithium ion batteries in electric vehicles. It's the meaning. Now we can see some Matlab simulation. I will show that will give you some clear insight about the charging. I'm going to share another Shiny ma'am.
Yes, sir.
My
Yes, sir. Yes, it's visible, sir. Yeah.
I hope all of you see this simulation file. Normally, lithium ion batteries, how they do charging is up to 80%. They will give current controller based charging. After that, they convert to voltage after 80% of SOC. That is a different case. For a simple understanding, I am going to do some simulation analysis. Okay. Wait a minute. Its response is very delayed. This is the battery. So if you see, to give all the parameters, you can see for the case which I already told. I'm going to give a rated capacity 100 ampere and voltage and initial giving us 0%. Just note it down. Voltage 12 volt, ampere hour, initial state of charge 0%. Okay, I'm going to analysis with the two batteries. See for a battery also. Slowly responding. So bear with me. So I am going to charge one battery. I already show the C rating also. Okay. 100 ampere hour, 12 volt, 0 SOC, state of charge, for analysis purpose. So at what rate I am going to charge is for 10 ampere hour, I am going to charge at the rate of 10 ampere. This is a programmable current source. What value I am giving is as will deliver us current. So I am giving 10. So 10 ampere at a constant rate. Okay. So I am going to simulate this. You can the state of charge. It will start from 0. This upper one is state of charge. Another is charging current, and the terminal of the battery. These are the 3 parameters indicated. Okay. State of charge, current, voltage. I request the participant to kindly mute your mic. The state of charge gets increased. Charging current is 10 ampere. From external battery gets charged. That's why it is indicated as -10. You can see the timing. Here it is seconds. Here it is mentioned as seconds. Sorry, actually, we are using a 100 ampere hour battery. So our charge for 1C at 100 ampere. So for since it is 100 ampere hour, I am trying to charge at 1C rate. Then I have to give 100 ampere. That's why I am giving 100 ampere. You can see the simulation timing here. It is in seconds. T. It is in seconds. This battery should reach 100 SOC, 100% SOC at 3600 seconds, because 3600 seconds is equal to 1 hour. So we can 68, 70, 75. I will start the simulation at the nearer to the range. Now I am starting the simulation. You see 3479 seconds. You see the SOC level, it is 96.65. You can check at exactly 3600 seconds. It will reach 100% SOC. That is fully charged. After that, it will remains in same charging level. We can't overcharge the battery. See, it will reach 100 at 3600. So that is the meaning of C rate. For the same battery, if I am charging at 2C, 2C means twice the rated. So 100 ampere hour. Okay, twice the rated means 200. I am providing the charging current 200. Ultimately, the battery gets fully charged at 30 minutes. That is 1800 second. At 1800 second, the battery will reach 100% SOC. You can check with this simulation. Now I am starting the simulation. You can check. Sorry, I have already passed. Now only I am going to simulate. You can check from 0 it starts. SOC starts increasing 24, 28, 30. I'm stopping 50. For 50% SOC, you check 51.27. It's around 922. Our estimate is at 1800 second. That is at 30 minute. It will reach 100% SOC. You see. 100 and I have stopped exactly 100 and 1800 and 802 1802 second. It crosses 100% SOC. That is the meaning, because you are charging the battery at 2C rate. This is how we have to do the charging analysis. Okay. What about 0.5C? That is C5. We can say it as C5. C5 means your battery rated is 100 Ah. So 0.5 of the rated, that is 50 ampere. 0.5 into 100. That's why I'm giving charging current. 5C means 50 ampere. Sorry, C5. C5 means 50 ampere for this battery. So I am now I am charging at the rate of 50 ampere current. Now our estimate is definitely more than, it will take more than hour. For C5, that is 0.5C, it took 2 hours. 2 hours means, if you convert that into second, mean 7,200 second. At 7,200 second, it will reach 100% SOC. You can check. I'm starting the simulation. See, battery SOC gets increased 10, 11, 13, somewhat slowly charged compared to previous simulation. You see, going to cross 3,600. That is 1 hour. Nearly now I have stopped the simulation. See, 40. You check the timing, 2,882. It will reach 50% at 3,600 the second. I will stop. Now you check 49.23. Exactly stopped at 3,544. For 50, surely it will be 3,600 the second. I start the simulation. It crosses 50. So our estimate, it will reach full charge 100% SOC at 7,200 second. I will try to stop at the exact place. Let's see. Anyway, I stopped around 97.75. You see, the second is 7,037. So it's about charging of batteries. If I again start the simulation, it will cross 100% SOC. I hope you all understood about C rates. What is C1, what is C2, C5. In simulation, we saw for 3 cases. First, we saw for 1C. After that, we saw analysis for 2C. And last, we saw analysis for C5 cases. We also compared the charging time. So another main issue in batteries are SOC estimation and also balancing of batteries. So any of you interested in doing your research in batteries? Actually, my area of research is solar PV and energy conservation. Anyway, for the past 1 or 2 years, we are working on batteries. We are trying to set up facilities also because of a huge amount. Still, we couldn't get the exact facility. We have batteries for lithium ion, lithium ferrophosphate. We have cells, we have chargers, but we need more additional facility to do the charging analysis in real time. That's why we are waiting. Anyway, I will tell you the research issues in batteries. One is charging time. We have to reduce the charging time. How? It may differ, whereas number of batteries are connected in series. Okay, for that I am going to do some simple analysis. Okay, instead of doing analysis with one battery, if you go for larger rating, definitely your battery pack gets connected in series in most of the cases. In few cases, it will be series and parallel also. Okay, now I am going to do some analysis in series case for the same rating, 100 Ah, 12 volt and 0%. I am also going to convert this battery rating 100 Ah, voltage 12 volt. SOC is 0%. Okay. Now I am going to charge at a rate of 1C. You can, you are really interested, you just note it down what I am doing. After that, you can try on your laptop or your desktop. So I am going to charge both the batteries with the help of source at 1C rate. 1C means rated current, that is 100 ampere rate. Both the batteries get series. So same 100 ampere current given to both the batteries. So exactly for this scenario, the battery gets fully charged at 3,200 seconds, exactly at 1 hour. Okay, you can see both the batteries are SOC levels are increasing in a similar manner, same, because of same SOC level. Both the batteries are in same SOC level. It reaches, sorry, I stopped the simulation. Again, I run because we didn't see the second. I want to show that also. Try to stop. It's fine. Now both the SOC, I stopped, pass the simulation. SOC at 98.22, both the batteries are same. You see the second 3535. So it all will reach 100%. Both the batteries will reach 100% SOC exactly at 3600 seconds. Okay. Then we can do another one analysis. Why not batteries in different SOC? Depends on material, charging, lot of environmental factors. The batteries SOC level may vary. So instead of having a battery SOC level at same, okay, before that we can do another thing also. I am going to make the SOC as 50. Here 50% charge is available for this battery. Here also 50% charge, state of charge already available. Then this both the batteries will fully charge at 1800 per second, because already 50% charge is available. Okay, already 50% charge is available. So in order to make fully charge at the 100 ampere charging rate, 30 minutes is enough. Is it right? There 0% SOC. Now the batteries already they have half of their rated capacities. So now I am going to start the simulation. See, at the 1800 second, it will reach. It will start from 50 and reach 100% to SOC at exactly. Now sorry, again I start the simulation instead of passing. It starts from 50. Going to stop nearly 97.8, both the batteries. It took 1722 seconds. At exactly 1800 second, it reaches both the batteries reaches 100% SOC. Okay. Whereas in the case, both the batteries are in same SOC level. What I am going to do is I am going to increase the charge SOC level. Here I am going to have it as 75. Here I am going to have it as 25. Okay, you see, this battery is at 25% SOC. Another one battery which is connected in series is have 75% SOC. Now I am going to do the same charging analysis. At what time both the batteries gets fully charged? This battery reaches fully charged very quickly. Okay, at that after that only this battery crosses 50, 79, 80. The total time required to fully charge both the battery packs. It took around 2700 seconds. Okay, you note it down. Here SOC is 25, here it is 75. So to fully charge the battery pack, the time required is 2701. What I am going to do is another one thing, using charge balancing. Normally in batteries, battery balancing techniques are there. They are using two types of techniques. One is passive balancing and another one is active balancing. Passive balancing is nothing but balancing of SOC level of batteries with the help of passive elements such as resistor. So they simply connect a resistor across the battery and discharge the mismatch charges. So the energy gets wasted in that passive balancing, but battery gets balanced. That is the thing happened in most of the batteries. You can check with a lot of manufacturers. I inquired with Robert Bosch and another TI. They are using batteries. They are using a passive balancing only. So there we are wasting a lot of energy. In order to balance, they are wasting the energy. Another balancing type is active balancing. What we can do is with the help of polytronic converter, the surplus energy in the battery can be transferred to another battery with the help of polytronic converter. That is possible. I think you know about the polytronic converters. That is mainly DC to DC converter. That DC to DC converter can able to transfer power from one battery to another battery. You assume that here it is 75 and it is here it is 25 SOC. Here the energy is higher compared to battery in in this position. So what I am doing is I am using a power electronic converter, that is a DC to DC converter. I transferred 50 25% SOC, that is energy which is equivalent to of 25% SOC is transferred to this battery. So what happened? This SOC will become 50 and this SOC will become also 50 because we are transferring the energy equivalent to of 25% SOC is transferred from this battery to this battery. Now we have balanced both the batteries. Here also 50%, here also 50%. For the previous case also, if you see the capacity, the same energy capacity is same. Here also same. What the difference is, we are balancing both the batteries. Now I am going to charge. After balancing, if I am going to charge, means to get reduced time. You see, there it is 2700. I'm going to start the simulation 99.18. You see, the charging time is 1770 only. For the previous case, to completely charge your battery pack, fully charge your battery pack, it requires 2770. Now for this case, it requires only 1770 only. So almost 1000 seconds we have reduced by balancing the batteries. After balancing the batteries, if you are charging, means the charging time gets reduced. So our electrical engineering faculty members can do quick charging.
Prince, sir. Prince, sir. Can you hear me? Prince, sir. சரி சார் சரி.
டேய் அதுவே லீவ் ஆயிருக்குடா பிரேக் காட்டுறது.
Ma'am, can you hear me? Shiny ma'am.
Yes sir, yes.
Wait a minute. Ma'am, you have to enable screen sharing, ma'am.
Now you can share your screens. Hello, can you hear me, sir?
Yes, ma'am. Yes, ma'am. Where our slides are visible?
Yes, sir.
Okay. So can focus on charge balancing also. That is the hot topic in batteries, especially in electric vehicles. Large amount of battery packs are there, and the master slave concept based battery management systems would be there. In that you can focus on battery balancing to reduce the charging time. And another one important issue in battery is state of charge estimation. I think most of you heard the name SOC. The estimation of that the state of charge is the biggest challenge. We also faced in mobile phones. While purchasing the charging level, it indicates correctly. After a few years, many of you notice that from one particular point of time, your charging level gets drastically gone down. If you take my battery, it will come up to 20% of SOC in a slow manner. After 20% of SOC, it will reach 5 and less than even switch it off within 2 to 3 minutes. That is the problem. That is due to lack of SOC estimation correctly. We are indicated that this is your battery charge. What actually happened is for me it is showing that 20% SOC. It will not be correct. It may be 5 or less than 5. That's why battery gets drained very quickly. It happen in all the batteries. Depends on batteries capacity, manufacturing, all those things. But that estimation is one of the biggest challenge in lithium ion or lithium ferropositive batteries. So what we can do is we can do mathematical model, and with that we can able to find a solution also. With help of machine learning neural network, we can provide a solution for state of charge estimation. Now I tell you simple example how we can uh, go with for a student project we can give. For research you have to do more than that. You have to include lot of parameters. Okay. What I did is I collected data from simulation, SOC data and VOC data. Here instead of VOC you can take VM voltage, terminal voltage of the battery, and a few parameters in later also. This will not be the exact, uh, but from this value you can able to know how we can use neural network for estimating the SOC. So I am having two value. One is SOC and another one is VOC that I obtained from the simulation. Okay, this is for one battery pack. I think it's for 48 volt battery, I think. Anyway, this kind of data you can provide for neural network. How we can means a lot of tools are there. I'm going to explain a basic tool. You can type NN tool in command window. To type NN tool in command window, you will get a GUI flag for running the neural network based slowly responding. Kindly wait. So this kind of window we open. Here you can directly feed input and output data to train your network. Okay. What I am going to do is I am going to give this VOC. So for us, I want to know the SOC level. So I am going to give this VOC as a input data. Basic thing. So, more parameters there will be fine. For time being, I am using two parameters. One is input and output. For input, you can take a number of parameters. IP. I name it as IP. I am giving this value, VOC values. So if you type IP, these are the VOC values. Okay. And the output is OP. I'm going to copy paste this values. SOC value. This is output. What we need. Okay. You can see the corresponding outputs. So I am going to feed these two values. Import. Okay, input data, that is input. Okay, I input. Okay, after that, I am selecting output data as a target data. That also I imported. Okay, so now see, you see both the things imported in the input data, it is there, IP, target data, OP is there. Now I am going to select the network. I'm going to use feed forward. Many algorithms are there. You can select any algorithm. Most widely used feed forward back propagation algorithm I selected. Input IP selected. Target data OP. You can vary these training functions, number of layers, number of neurons. All those things are the parameters to make your neural network more accurate. So I make others as a default and create a neural network. That is with the name of network 1. I create. Sorry, it's slowly responding. Recent Matlab versions directly you can give the value, but the remaining things are same.
Consumer and automation based designs. Then comes our projects in terms of prototypes and so on. So you are being exposed with the topmost product design in engineering, which works in a rugged environment, very different environment, which are totally unimaginable. There are only models.
Shiny ma'am, kindly ask participants.
And ensure that it is 100% non-defective, and we need to put it into space. Actually. For that, understanding of mechanisms, process, and functionality of the satellite is very much necessary and essential.
Ma'am, Shiny ma'am, can you hear me?
Prince sir, can you hear me?
Yes, ma'am. But I am hearing some others talk.
Then we have identified.
Participants, please mute your mic. Participants, please kindly mute your mic.
Yes, ma'am. Okay, thank you. Now you see the network here. You can double click to see the parameters. That you have to again select train, input data and target data. You have to train the network. That's all. Depends on number of training and the comparison. You can came to conclusion that the training is enough, or else you have to train more times to get the accurate output. You see iteration and performance here. For me, it's slowly responding. That's why more time is consuming. Let's just check whether network gets trained or not. Okay, anyway, time is also better. We can leave because it's slowly, very slowly responding. Here, after a training, you can see the output data. as well as input data. Here, the output is almost same. You can check the error also. After training, you can check the error values also. Error value is almost 0. So training is sufficient. Means here we simulated for less complex data. That's why the error is 0. Okay, now the training is enough. We can check for our own data. Okay, what I am going to do is I am going to export this network. That is network 1. So now we have trained a neural network with our input and output values. This network 1 is exported to workspace. Yeah, you can see in our workspace network 1. So to generate a simulating file, you can type gensim of network 1, the file name. One minute. Here, I think the new simulating file will generate like this. Through that, you can check your network by feeding the input data. Here, due to some issues, input and output terminals are not there. Okay, we have to try it with different data. Just tried. The format, I think, is reversed. That's why error is there. So I am changing. I will delete all the data and I am going to refeed it. Import IP data, OP target data. Close. You can see after that you select here. I have created a network. So created. After that, I'm going to train that network. Output. So some mismatch is there. That's why the simulating file does not open correctly. I change that output file, given format. Again inputting output that is target data. Change the output train network. Change the network also, or else. Try last week. So some error is there. Okay, I tell the things you can try. Okay, lot of tools are there. Here the input and output data doesn't match. That's why it is not trained correctly. Or else you will get the correct results. I couldn't generate simulating file also. I already generated, but that should have input. Does not have input. That's the problem. Anyway, you can try like this. Instead of VOC, you can try VM, temperature, and other parameters you can take to find the SOC of batteries. For analysis purpose, I used SOC and VOC. You can have different parameters in order to accurately predict your SOC levels. That is also biggest challenge in batteries. So these are the things. More than that, converters also emerging in electric vehicles. To my knowledge, most of the industries they have well-versed powertronic converters. So in research, if you are telling any converters we have better function over that, means that is not successful for publication. So instead of focusing on converters, in smart balancing we can focus converters for balancing. For other BFDs, they have more efficient converters. So that is my suggestion. So these are facilities we have. We have lithium cells and the battery pack also we have. I didn't show in these pictures. We have lithium ferrophosphate with 30 Ah capacity, 48 volt. Lithium ion also we have 48 volt, 25 Ah battery pack, and we have lead acid batteries and chargers. Related to batteries, we have these facilities. And for SOC measurement also, we have meters. And thermal analysis, we have a thermal imaging camera, FLIR camera we have. So any interested, you can contact me for do research in battery related topics. Now I thank Department of Triply of PSN College for giving me this opportunity. I should thank Saktivel, who is our alumni. We should thank him for inviting me. Thank you. Any questions? I happy to answer the queries.
Thank you, Prince sir. It was a very wonderful session. Participants, you can share your queries. Any queries? Dr. Prince, sir, I have a doubt.
Yes, ma'am.
In neural network, you have used generalized regression.
Yes, ma'am.
Is there any specific reason for this
No, no.
GRN?
No, ma'am. I am using a simple data for let you know how to use a neural network in the GUI too. That's
Okay. Okay, sir.
but you can do a lot of analysis. Which one is giving better means you have to do comparative analysis. You have to really train and compare. Generalized regression normally used for linear kind of data.
Yes,
Feed
yes.
forward back propagation you can go with
Yes.
different layer and networks.
Okay, sir. Because I'm doing my research in the GRN, and that's why I'm asking.
Okay, you can do that analysis.
Any queries, participants? Shall we wind up, sir?
Okay, ma'am. Okay, ma'am. Thank you.
Thank you. Once again, I thank Dr. Prince sir, for accepting our request to present in this FDP session. And I also thank all the participants who are all joined today in this first day of FDP. And tomorrow's session is the resource person is Dr. Rajashekharan sir. I will share the Zoom link presentation in our WhatsApp group. The time is same. It's 10 a.m. So once again, I thank all the participants and the resource person. Thank you. Thank you, sir.
Ma'am, when will you send the feedback, ma'am? Excuse me, ma'am.
Into ma'am. என் நேம்ல யாரோ இருக்காங்க.
அந்த பக்கம் அந்த
இன்னும் மேம் இது பாருங்க, எனக்கு ஆடியோ வந்துட்டு இருக்கு. பட் இன்னும் நீங்க இருக்கீங்க, பாருங்க.
இப்பதானே முடிஞ்சது, சக்சஸ்ஃபுல்லா முடிஞ்சது இருக்கு.
அப்ப எனக்கு காமிக்குது எப்படி? எல்லாம் ஸ்டூடண்ட்ஸ் எல்லாம் ஸ்டாஃப்ஸ் இருக்காங்க.
இல்ல மேம், அவங்க இது பண்ணாம இருப்பாங்க. நடக்கல, நீங்க ஜாயின் பண்ணிருப்பீங்க மேம். நீங்க அது க்ளோஸ் பண்ணாம
மியூட்டே உள்ள மாட்டேங்குது எனக்கு. நீங்க பாருங்க,
நீங்க பேசுறீங்க, நானும் பாப்பேன்.
பாருங்க, மியூட்டே விழ மாட்டேங்குது. ஒருவேளை கேட்காதுன்னு நினைக்கிறேன்.
கீழ மிஷன்ஸ்ல அப்ப அந்த லாஸ்ட் எண்ட்ல
நீங்க இப்பதான் ஓபன் பண்ணீங்க. ஓபன் கொடுங்க, ஓபன் பண்ணுங்க.
சரி. ஹலோ, நீங்க
இந்த மேம்
நான் இவருக்கு எப்படி நன்றிங்க பாத்தீங்களா? மீட்டிங் நடந்ததானே? மீட்டிங் எது
இல்ல, அப்புறம் என்ன?
FTP hours, FTP was first day of our FTP was successfully completed. Thanks to all the participants.
அப்ப நான் இப்ப நான்
ஜாயின் பண்றீங்க. அது இது பண்ணாம என்ன?
Sorry to disturb all of you. மேம் எனக்கு இப்ப கேக்கலல்ல.
நான் ஆஃப் பண்ணிட்டேன்.
அவங்க வாட்டி சொல்லிடுங்க.
அவங்க
எல்லாம் போயிட்டாங்க.
அவங்க பேசவே கேட்கல, நீங்க பேச கேட்கறாங்க.
மேம் இப்பலாம் அசிங்கப்படுத்தாதீங்க மேம். மேம் இருந்தாலும் ஒரு சில ஆட்கள் கேட்டுட்டு இருக்காங்க. மேம் என்னோட ஹேங் ஆகுது மேம்.
இப்பதான் உள்ள போகுது. முடிஞ்சிட்டா அதான் கொஞ்ச நேரம் கூட்டத்தை சேர்த்துட்டாங்களா? 100 பேர் தான் அலோவ் பண்ணுது போல. இல்ல ஜூம்